Hello, welcome to the data channel. And today we will be discussing about data loading models, basically. And if we talk about data loading, when it comes to the data ingestion part of it, where we load the data from source to target, right? And we have different loading methodologies or loading models, what we can say. As you can see, these are the four major data loading methods. That's full load, which will be truncate and load. That means from the target you take the data and you load to the from source you take the data and you load to the target directly, and you do a truncate and complete the flush and fill. And there's an incremental load where we kind of append the data or upsert the data in the target system based on the data in the source. And there's a differential load based on the snapshot comparison, so that we'll be doing. And also there is a something called a CDC, that is a change data capture. It is based on the log, or it is based on some triggers. That is when the file arrives, or etc. So these are the details we will be seeing in this video particularly, and we will go one by one and understand both theoretically and practically what exactly each of these means, right? And I'll be using Spark here as a programming language to demonstrate with examples, right? And let's start with the full load. So full load is nothing but you have a source table and you have a target table, right? And the source table will completely replace the target table. So no matter what you have in the target table, so irrespective of whether the table is empty, whether its table is having already existing data, so it will be completely reloaded. That means the table will be completely truncated or deleted, the target table, and whatever the source will be there, the exact replication of source will be copied to the target table. So how exactly it works? As you can see, there will be delete of all the records in the data warehouse table. Here, data warehouse table we are considering as a target table, and we read the full data set from the source and load it into the target table from the scratch. That's what. That's how simply it works. And when exactly we will use it, right? Basically, we will be using it where the data is relatively small. That means where you are having a like couple of thousands of records, where like say for example you have a dimension tables, where like data is relatively small and it doesn't changes very frequently, and so basically it's not a transaction data, right? It is not a heavy table. So that case will be should be using it. Otherwise, the complexity, because if it is a huge data, like if it is a 1 TB of a table, so if you are truncating the 1 TB of table and reloading the table, it's not quite a logical way to do that. So that is why it should be quite useful only in terms of having a relatively small data. And so it is not reliable when the no reliable method exists to detect the change. So here we are not caring about what exactly the source system methodology to detect the change. So because we are not detecting any change here, our intention is to just take the data from source and update the target system, right? And also when the business requires full refresh due to the compliance or data integrity, sometimes some cases what happens from the compliance, regulatory and auditing perspective, the data has to be completely migrated on daily basis. In that cases, basically you should be going to like even the data is relatively huge or relatively larger, so because of this data integrity issues, compliance and regulatory related stuff, so in that case also you might still go to the full load, right? And what are the pros of having it? Yeah, definitely it is a simple, because from the developer lens you don't need to write a particular logic to detect any change here. You just read the data and override the target table, right? And one more advantage is consistency, because if the data are like very small relatively, then definitely you should go for it, because it guarantees the target is always in sync with source. Because if you write a delta logic or incrementally update logic, so sometimes you cannot guarantee the consistency because of the logic has not run or it has corrupted the data, right? So you have to rerun the data, etc. So that's always best to use when you have smaller data. So this should be the first choice for any developer if the data is small and even relatively small. So definitely you should go for full load. And what are the cons of it? So definitely, if the data volume is huge, if the data volume is 10 GB, 20 GB of data, and every day the data is getting updated and incrementally data is getting larger day by day, so then definitely you cannot use this, right? And also, when the table is unavailable, that means you are doing a truncate and load. The target table is getting truncated and loading, right? So during the couple of seconds or minutes, the data would be available. If there is a user who is referring to this table, so the data might be unavailable for a certain time period. So that is also a con, and this is a heavy input-output operation, and also might use compute power to do that operation. Basically, it is a input-output heavy. It's not a memory; it is more of I/O related stuff, right? So let's take a simple example, right? So refresh data set I have taken here. So refresh data set is nothing but I have taken all these data sets as an input. So as you can see, it is a source data set, target data set, snapshot yesterday, snapshot today. So basically it is having three columns, right? And we're calling it as the ID, name, email, last updated, right? And I'm able to write it to particular locations in the my Databricks file system. So to see the when I refresh the data, so it basically get all the data into these locations, which is given here, right? So here, when I'm doing full load, what the intention here is basically I'm kind of reading a file, right, from the source, and I do a show, and I also truncate the data, truncate the target, and reload the data. So that is the target table, and finally I will show that. Okay, so here it is quite simple, right? Like this is a source. You can see it is 314625, and we have a certain names here. As you can see, it is the exact replica, right, of the source. Source is the first one, and the second I'm displaying the target. So source and target are exactly replica because target is completely replaced by source. No matter how many times I run this, so this target will always be similar or equivalent to the source. So that is why we are doing a truncate and load here. So the next one is incremental load, which is there are two types where we call it as append or upset. So the definition of this is only the new rows in the source or the modified rows in the source since the last load are processed and returned to the target table. That means let's take an example. You have 10 records in the source and you have 5 records in the target, and out of 10 the 5 is already there in the target, so there is no need of rewriting those 5 records which is already there in target. So we just need to write the new records which is extra, which is delta, right? So that is what we call as append, right? And there might be case where the existing records which are already there in the target system might get updated. Like suppose if there is a salary of an employee or a customer location has changed, right, in the customer table, so that location has to be updated. So that is, we call it as upsert. So these are the two different things here when we are doing an incremental load, that is append or upsert. And how exactly this works? So this to make it work, we have to write a certain logic as a programmer. So that logic is like you need to find the mechanism to track the changes. So is it might be a timestamp column, it might be a, like say for example, load date, update date, something like that. Based on that, you can identify which is the new records or the modified records, and write that logic accordingly. Or you have the surrogate keys, that means the IDs, where it is incrementally getting created. So based on that IDs also, you can identify which was the last max ID in the target table. So after that, whatever the IDs has come in the source, based on that also you can write the logic. And one more logic is like we can have composite primary keys also. Like you can have certain combinations of composite primary keys, based on that composite primary keys also. You can write a logic where you can to identify if there is any changes. So basically, generally we use either the key, that is a surrogate key, or the primary key, or we'll be using the last updated or the any kind of a timestamp that we have. Okay. So when we will use this, right? So when the data set is large, because if there is like in the target system, you already have loaded 1 million record, and again, if you want to like do a full load, again, it might require complete flush of 1 million record and load. So that case, this might the full load like in that case, incremental load is feasible because you have a large number of data set. You cannot afford to do a full load, right? Then what you will generally do is you identify only the changes and you update in the target table. And the data is high frequency data. That means it is refreshing like a transaction date table is there. You are getting the data every day basis and every hourly basis. So that case also you cannot afford to do a full load. So you need to go for an incremental load, and incremental load is also called as a delta load because you are just loading the delta part of it. And what is the pros of it? It is efficient and faster, especially in terms of the huge data, volume of data, and the transaction tables, which are like fact tables. And it is more scalable for the large data sets and volumetric growth with the good volumetric growth. And definitely there is some cons. That means the detection logic as a programmer that we write should be very accurate, and it should be consistent. It should work consistently, and the complexity of writing the logic might actually depends actually, right? So because you need to write a logic in such a way that you take care of the deduplications and any conflict resolutions, etc. So those are the theoretical part of it, of the incremental load or delta load, what we call. So we'll see how it works, right? So I have two data sets here. One is a source data set, where is a source data.csv and target data.csv. So we read both the data here, and we will add a column called last updated for both of them, and we will just show that. Okay, let me first show that records as it is, what exactly the source data looks like and target data looks like, right? Yeah. So as you can see, like in source we have like around 6 rows, and in the target we have just 4 rows. And also like if you take Carol, so Carol last updated was 5th Jan, but here it is 25th December 2024. That means in the target is the old data, and that has to be updated. So we are writing a upsert logic here. It is not a append logic. So append logic will actually just it don't touch the existing records, right? Like suppose if there is a Carol, Alice, David, and Bob is already there. So if there is any record has been changed since the target loaded, so it will not touch that rows in the target. So it just loads the new data that is arrived. So usually, generally, we don't use use that logic. So most used logic is upsert, where we insert the new rows. Suppose Bob and like suppose Eve and Frank is not there, so those has to be inserted. That is the first priority. And next is if there is any update happened, like any rows has been updated, so that has to be updated, right? And here in this logic, if we closely see, we are using last update time as uh, the timestamp as a column. So similarly, you can use ID as a column. So if you want to write a ID as a column, so then you have to write a certain logic where it takes the max of ID. Here it is 4. So whatever came after 4, so you can use that. But last modified, generally the timestamp we will use it because we are doing upsert here. If any record has been changed from previous load, so that also we have to take care, right? So the logic here is simulate the last run. So in this part, I'm just trying to simulate the last run. So last run I'm giving as 31st December. So in this case, I'm taking 31st December, but generally you can take it as whichever if you see here, 30th December was the last date. So that's why I'm taking 31st here, which is the next next run date. So generally, this last date will come from the your database or wherever you store the metadata, right? So you need to keep that track of metadata. It might be in the database, or it can be in the file system. So basically, you can keep that anywhere to keep track of this load. So it should be runtime. It should be able to update it, right? Whenever the today's run's completed, so it need to update to the today's date. So then I'm trying to get the incremental data frame here. So what is incremental data frame is nothing but I'm trying to add the last run as a like here I'm taking the column filter, which is last updated is greater than the last run. That means whatever data has been updated from the last run. So those data frame I'm taking into the incremental data frame. That means that will become a delta data frame here. So those delta records, what I'm doing is I'm joining with the target table. So target table with the delta records, I'm joining. So that's a join condition. And based on what I'm joining here, based on the ID I'm joining. So ID is my join condition, and I'm doing a left anti-join. And so that actually this particular line, what it is doing, it removes the rows in the target that exist in the incremental table, basically, right? And next step is we do a union, basically union by name, the target and the incremental data frame, whatever we have, we actually do that a union. So union by name. So that is a merge data frame that will become my final data frame. So that final data frame I'll be writing into the this target location, and I will read the target location and display here, right? So let's try to execute this. Okay, so there will be three results here. One is source, and the next one is target. You can see source is this, target is this, but what is the result? The final is the result, right? If you see here, the source part of it, so already Carol is there, the target also Carol is there, but the timestamp need to be updated for the Carol, and for the Alice, nothing to be updated because it is already 31st December, the last updated. And for the David, the timestamp need to be updated again, and for the Bob, timestamp is already updated, no need to do anything. But Frank and Eve has to be appended, right? So let us see the final result. So Frank and Eve has been appended, and Alice, previously it was 30th. So now also it is 30th because in source also it is 30th. And for David, it was 1st Jan, but now in source it is coming as 6th Jan. So that is why for David it is 6th Jan. Similarly, you can see for if you take David as well. So David was 1st Jan 2025, but now it is 6th Jan, right? So you can see it has been updated to 6th Jan. So that is how we call it as a incremental load or append or upsert, or we also call it as a delta load. So next we will discuss about differential load, that is delta based on the snapshot comparison. So let's imagine, so in the previous example, we had talked about delta load. So delta load, as we discussed, it is completely based on the ID or some column that is timestamp based, or you need to have some surrogate key or a timestamp. Basically, you are dependent on particular key there. Where that key might be a surrogate key, composite key, or it might be any primary key as well, or a timestamp, which generally is a load or update timestamp, right? But let's imagine the source table doesn't have any timestamp column or doesn't have any primary keys. So it might happen, right? In real world scenarios, there might be tables which doesn't have any surrogate keys or any uniquely identifiable columns. Basically, if you don't have any unique identifier or if you don't have any timestamp, then you cannot practically write a logic for incremental or delta load. So that cases you have to take little harder way, unfortunately. That is, we call it as a differential load or delta based on snapshot comparison. So here, what it does is it takes the source data, it takes the target data, it does the complete snapshot comparison from like apple to apple comparison, and to detect whether there is a inserts, there we need to do updates, whether the deletes are required. So basically, it takes apple to apple comparison, and it identifies which records are new, which records are deleted, which records are updated, right? So how exactly this works? So this works based on the extract a full snapshot from the source system, store it, and compare it row by row with the previous snapshot. So that again we have to do it programmatically. Um, and how does it work? Like how does it identify inserts? So inserts basically it is a row in current snapshot, but not in the previous one. Updates means row with the matching keys but different values. Okay, some rows are there but values are a little different. And deletes, how do you identify deletes? Is row in previous snapshot but not in the current one. uh, so I know like there might be a question that we're talking about keys, like are not present. So here we're talking about the keys are there, but it's not reliable, right? So if the keys are reliable, like surrogate key, which incrementally update or generates, right, incrementally, so then we can rely on that for the delta load. But here in this case, if you don't have such reliable keys which where incrementally are getting like getting generated like a surrogate key, so then unfortunately we have to go with this snapshot based. And when to use this? Basically, when there is no last timestamp or CDC mechanism, change data capture mechanism, or last updated is not there, where we can, if it is there, we could have gone to the previous one, that is a delta load or incremental load. And source doesn't support such incremental logics. Unfortunately, that happens in a lot of the cases where they don't have reliable primary keys or reliable timestamp, especially. So then you have to use for this approach, right? And what is the pros? So pros is it is independent of source system features. That means you're not dependent on whether source is supposed to supporting the logic of incremental or not, and it is flexible, works even with the legacy systems, because legacy system doesn't support like lot of the tables doesn't have that last updated or modified timestamp. So then, unfortunately, we have to go for this approach. And cons, yeah, definitely there is a lot of cons here. So it is high compute due to the comparison logic. If there is a huge tables that you're comparing, so then you need to be really careful how to optimize that code, because otherwise it will going to take a lot of your compute, right? Because you're doing apple to apple comparison. And it definitely need additional storage here to keep the snapshot. You need to take care of caching them, utilizing the memory effectively, etc. And latency also, it cannot support the real-time loads or also near real-time loads, because it takes a lot of time to do apple to apple comparison, and then the loading process takes certain amount of time, right? So those are basically the theoretical part of it. And coming to the practical, see, these are the implementations which I'm writing it from my perspective. So there might be different kinds of code that you can write here. So there is different logics you can write here. It is just one way I'm showing to apply this logic and understand this concept, right? So you will not write the exact same code. So there will be different, you can choose to write in different ways. So I am using joins here. You might use SQL, Spark SQL. So I'm using data frames. You can use pandas, so etc. Right? So this is the logic that I'm writing is like is not it doesn't depend on what exactly the programming language or the method that I'm using, but conceptually it should it is to explain what exactly we are meant to explain here, right? So now coming to this code part of it. So I have the source snapshot, I have yesterday's, and I have today's snapshot. Okay, let's see what exactly the yesterday's and today's snapshot look like. It's today and yesterday and today. Yeah, let me comment this out for now. execute. Okay, so as you can see, the Bob is not there, right? Yesterday, Bob was not there. That means here in the target table, he need to be inserted newly, right? So that is why Bob has been identified here. And also, if you see deletes, right? So Eve is present here, but it is not present in the source, so that needs to be deleted. Eve need to be deleted, right? So that is why Eve is identified as a delete. And what is updates? So if you take these two, what is the updates is Carol is a email ID is updated based on the ID we are writing the logic. Based on the ID, it is able to identify Carol's email ID has been updated, right? So that is why it is giving me these three. So we have identified these three, and we can merge that into the final data frame and write into a target system. So I'm writing just the logic here. So this is how the logic of uh, differential load or delta based on snapshot works, right? So generally, we use this also in data engineering practices where you don't have the timestamp, as I mentioned. So it is worth to understand the concept of it, right? And in Databricks, if you are using Spark SQL, there is a command called merge. You can use that command to do this kind of logic to identify and write that based on the snapshot comparison. Okay. So next we will discuss about change data capture. This is basically we call it as a log based or a trigger based. That means suppose your source system is a database, and you want intention is to capture the change, right? That means what has been changed since the target is loaded, a target table is loaded. So that is based on maybe the database logs that you will be having or the triggers that you'll be having, or it might be simply getting like if you're using Spark, Spark streaming and etc. So based on that logic, whether the file arrival when that file arrived. So based on that event, also you can run this. So this is the major difference here is it is majorly the real-time processing compared to the delta loads that you saw and the snapshot based delta logic that we saw the previous two logics. So the CDC is a real time, right? That means you do not run the code. So if you implement this programmatically, so as soon as the source changes, immediately the target changes. It is very real time, almost near real time, or sometimes it is very near real time. So what are the different types? As I mentioned, it might be if you're using database, you can use the database logs as the events, or if you're using a file system, you can use whether the file arrived to the system. So that based on that, the arrival of the file can be used as an event. So basically, you need to capture an event. It might be based on a log that is behind the scenes, or it might be in the file system. The file has arrived newly. Okay, so for example, you might be using Spark streaming, that is Spark structured streaming, where it will be running 24/7 to get to see whether the new data has arrived. So that is what we will be seeing in this example. Or other example, you can just go and read about autoloader and delta lake. Basically, you have a delta live tables. So even that works on a similar concept. And even if you are aware of Kafka, right? So Kafka also does the same thing. It does the change data capture. You can even write the logic of updating the target system based on what has changed in the source system for Kafka. So those are the examples, but conceptually to make you understand how exactly this change data capture looks, I'll be considering Spark structure streaming in this example, and I'll show you that. How it works, right? CDC process continuously read the change log. So that is quite important, right? It is continuous process. It is not like you have to manually come and run it each and every time to bring the changes from source and target system, or you need not to have a schedule anything here. So because it is automatically bringing the changes from source system to target system. So when exactly you need to use this? Obviously, when there is a use case where you need to bring the data in real time or near real time, and basically where we're talking about modern data pipelines where we have streaming ELT or ETL processing, and the systems with a high data change velocity. So in that case, you can use it. and that becomes your pro, right? So because you are getting real-time updates to the synchronized to the target table, so that is a pro. And what is and the data is more accurate, and as much as possible because it is real time. And what is the cons? So cons is it is complex setup required because you need to write a code, you need to have that pipelines running. So sometimes there is a lot of compute required, and sometimes there is you need to have that initial setup of uh, uh, doing that CDC enabling that CDC, and also the may require elevated privileges and impact source DB performance because you're reading the database logs. Then it might be that is one of the cons if you're especially going for a database change captures. And some databases doesn't expose the logs, obviously, so that is other cons. But definitely, you're using a file systems. Then this cons will not be applicable because you just read that as an event of the file arrival, right? All right. So now that we have source location, target location, along with that, it is important to note we have checkpoint location, schema location. Anyway, it is not mandatory if you are already having a infer schema here. But what is important is checkpoint. So checkpoint location, what you are specifying here, so need to be specified because that is how your Spark streaming keep track of records or which are already read and which is already written, and it doesn't read the data which is already read, right? So that's quite important. And so what we will do is basically before starting this Spark streaming, we will actually see what is there in the source location, right? So currently you're not expecting to have anything. Yeah, so we don't have anything in the source. So I will go and upload in the source location. That is, I have a source data v1 here. Let me upload this. And immediately when I upload it, so it should be there in that location because it's a DBFS. So then I will go ahead and start this streaming. So hold on just a second. Okay, so let me start the streaming, right? So what's happening here now? So I'm writing a Spark streaming code. So spark.read stream. It is reading the location. And as you can immediately quickly see here, it has read certain number of records. That is six to seven records it has read, and it has actually started the stream, right? So it is waiting for the next set of rows from the source, but it has not got any source. Let us see what is there in the target location right now. And it is important to note that, so I'm writing it as a CSV. So it has written one CSV file here in the target location, right? And this is continuously running. This is a Spark streaming code, right? Read stream and write streams are continuously running. What I'll go ahead and do is I will upload a new file. I will just rename this file to v2, and I will go ahead and upload this in this source data. Sorry, source location. Okay, so immediately when I upload the data, let us come and see here in real time it has captured that, right, from the source system. And also let us see whether what happened in the target system. Target system also it has written in real time. Okay, but however, let us try to read this location, right? Spark.read. CSV, and I will give the location. And you can see here, basically what happened is when the new file came, it has actually written that new file records also to the same location, the target location, right? And if you want to apply the deduplication logic, again, you can write that to deduplication logic somewhere here, right? But I'm not writing any deduplication logic, so that is why whenever a new file arrives in the source system, it is going ahead and writing it to the target table. Basically, this is what we call it as a CDC. Whenever there's a data change happening in the source, automatically it will be captured to the target system. Uh, so this is just to make you understand conceptually. So like code wise, you can write it into n number of ways how you want to do it. So like deduplicate logic you can apply here, etc. Right. So finally, if you want to compare this, all of these features that we discussed, different types of methodologies of data loading, which is full load, incremental load, differential load, and CDC, right? So basically, when the data volume is very less, so just straightforward go for full load. And if the data volume is huge, so then you need to weigh other options like what is the complexity. So if the complexity is definitely the complexity, if you want to keep it medium, you need to choose the second option is definitely an incremental load. You need to have timestamp or surrogate key. If you have that, the second option is incremental load. And if you have a use case where the performance is of importance, so then you have to use full load, obviously because the performance is very good in terms of the performance required is very low here. And if it is a real-time data that you want to have sync in real time, so then there is only one option, you have to go for CDC, but you need to take care of any deduplications, etc. here. That is why the performance is actually it takes a lot of performance here. It takes a lot of compute. Okay, and here change tracking is required or not if you see. So here it is not required, and differential load also it is not required because it compares apple to apple comparison. But in terms of incremental load and change data capture, the change tracking is required. It does change tracking internally. CDC does change tracking internally, but in terms of incremental load, you have to write that logic. So basically, hope you were able to understand actually what are the different types of data loads that you'll be doing when which type of data loads you need to choose. There definitely there will be no single answer to do that. So what happens in the real time scenario is we might end up in having a hybrid scenario where for small data sets we enable the full load. For incremental data sets, we like in the delta kind of logic where we have the timestamp columns, we might go for incremental loads. Where we don't have, we will go for differential loads. And a few cases, like say for example, transaction details where you are capturing certain KPIs, your key business KPIs. So business wants that data to be updated near to real time. So those tables or those data sets, I will put into a CDC kind of a logic, so that the business can get the real near real time touch and feel of that instance of the data sets. Right. Hope this was useful. Thanks for watching.